In this video, I'm going to find the integers in the range 1 to 20 that are divisible by 2, and the integers in the range 1 to 20 that are divisible by 3, and the integers in the range 1 to 20 that are divisible by 6, and the integers in the range 1 to 20 that are divisible by 2 or 3. So to answer the first question there, I'll use a rudimentary method. For this method, I'll just list the numbers 1 to 20 and I'll call it a set S. So the set S is the elements 1 to 20. So the numbers that are divisible by 2, I will denote them by the set S2. So the set S2 is numbers that are divisible by 2 which are in this set here. So the set 2 is those numbers 2, 4, 6 up to 20. So the cardinality of S2 there, if we count those elements, we see that there are 10. So we have the cardinality of S2 is equals to 10. I now move on to the second question there, the integers in the range 1 to 20 that are divisible by 3. So in this set here, we look for numbers that are divisible by 3, and I'll call that set S3. So we have S3 as the elements 3, 6, 9, 12, 15, 18. If we count those numbers, we see that there are 6. So we have the cardinality of S3 is equals to 6. I now move on to the third question there, integers in the range 1 to 20 that are divisible by 6. The integers in this set that are divisible by 6, I'll call those integers set S6. The set S6 here is 3 elements, so we'll be having that the cardinality of S6 is equals to 3. So that's what you are having there. Cardinality of S2 is 10, cardinality of S3 is 6, cardinality of S6 is a 3. So what I used there was just a rudimentary method counting the elements one by one. But when the range is a bit large, it might be difficult to count those elements one by one. For example, in the question number 4 here, where we are having up to 500. So there's another method of using the floor value. So what you do when using the floor value, when looking at integers that are divisible by 2 in the range 1 to 20, what we do is we look at the largest number in the given range, and it was a 20. We would find the floor value of 20 divided by the 2. So we would say that the cardinality of S2 is equals to the floor value of 20 divided by 2. The floor value of 20 divided by 2 is a 10. And then for the cardinality of the elements that are divisible by 3, our range was up to 20. So we'll be saying 20 divided by 3, then take the floor value. So for the cardinality of S3, it will be the floor value of 20 divided by 3, which will give us a 6. And for the cardinality of elements that are divisible by 6, we are still looking at our limit there. It was a 20. So we would say that the cardinality of S6 will be the floor value of 20 divided by the 6. And that would give us a 3. As you can see, the cardinalities that we are getting here, they are equal. So this method of using the floor value is easier, especially when you are having a larger number like 500 there. Then another thing that we can note from those sets, if we look at the set which has elements that are divisible by 2 there, we have a 6, we have a 12, we have an 18. These 6, 12, and 18, they are also here in the set which is divisible by 3. So the 12 there and the 18. So these elements that are divisible by 2 and 3, we are seeing that they are the elements which are in this set here S6. So what we are having there is S6 is equals to S2 intersection S3. In general, when we are looking at numbers that are divisible by 2 and 3, we will be looking at numbers that are divisible by the product of 2 and 3. The product of 2 and 3 is a 6, so we'll be looking at numbers that are divisible by 6. So when you are having numbers that are divisible by A and B, we are looking at numbers that are divisible by the product of A and B. So I can now go on to the question number 4 there. It's asking for numbers that are divisible by 2 or 3. using set notation 2 or 3, that will be the cardinality of S2 union S3. And for the cardinality of S2 union S3, we can use the principle of inclusion and exclusion. It says that the cardinality of A union B is equals to the cardinality of A plus the cardinality of B minus the cardinality of A intersection B. So here we are having S2 union S3. So where we have the A here, we'll put S2. Where we have the B, we put S3. So we would have the cardinality of S2 union S3 is equals to the cardinality of S2 plus the cardinality of S3 minus the cardinality of S2 intersection S3. In this case, we are saying our limit there was a 500. So for the cardinality of S2, using the floor value, we would have the cardinality of S2 is equals to the floor value of 500 divided by 2, which gives us a 250. For the cardinality of S3, it will be the 500 divided by 3, then we take the floor value, and it will give us a 166. For the cardinality of S2 intersection S3, we said S2 intersection S3, the cardinality will give us the cardinality of S6. Numbers that are divisible by 2 and 3 are numbers that are divisible by 6. So when you are using the floor value, numbers that are divisible by 6, it will be the floor value of 500 divided by 6, which will give us an 83. Then I go on and substitute these values into this formula here, and to get 250 plus 66 minus 83, and that will give us 333. So we are having numbers that are divisible by 2 or 3 are 333 when we are looking at that range there, 1 to 500.